Okay, actually, this is a joint talk. I'm with Alistair, and so it's and the next talk is about the detailed progress about the text to graph query we have done in our end group and by Sony. So I will start with a quick start here, and um uh we just came back from the VLDB 2025, and here I put place a picture here about the accepted papers in the 2025, and you can see the top three are the graph and network data. Yeah, we are still in the main track. We are still in the track, and the second is about the AI the LLM related things. And when I try to search LLM in the research paper, the program structure, and I found 31 match the results, and it's almost I think most of the results are showed up in the title because I don't think there will be some authors named IRM. So so based on the 31, you can see the total accepted paper here is almost 760. So it's about 10% to mention LLM in their paperwork. And there's a single session about the natural language. The chair named the session to the natural language interface to data. And you can see some work like the Google people, they are trying to utilize Gemini, which featured as long context. They are able to process too many tokens. They utilize Gemini to process the NL2 circle task. And OmniSQL here they are trying to synthetic the text to circle data and a data set for training and evaluation. So and we also have on the day one of the VLDB 2025, we also have LLM and plus graph workshop. And Ozu, Tam Ozu, and Philip, they also be here. And Ozu has some work to share with. They also have some works on the LLM with graph, like the text to cipher translation. And so the point I'm trying to make that sorry, it's,
Oh, with some font issues.
okay okay so the left is the point I'm trying to make that the academia community we are talk the hot topic here is graph is data plus AI. But we are as graph guys, but we want to talk about the graph plus AI. So we have graphs and the users are there, and here we have the LLM. And what we can do is we can utilize the AI, the LLM for graph, like just Max said, we can model the graph. We can let LM to propose the graph schema, and we can let LM to analyze and to automatically extract the triplets from the documents and to model a graph. That's what we can use to utilize the LLM. And in reverse, we can use a graph for AI, like graph, the knowledge graph, they can reasoning, right? And we can use the graph reasoning, the result to enhance the generated output by the LLM, which we have some observed some projects like KAG, which we compared to graph IAG. KAG use reasoning result from the knowledge graph to enhance the result by generating the result by the LLM. So a typical application here, on the top of this slide, we can use GraphQuery. We can use LLM to help the users to talk with database. A common input from our users in and group, they said, "Oh, Gremlin, G-code, Cypher is too a bit difficult for me to learn and compared to the Circle." So we are thinking about if we can use LLM to like the text-to-graph projects to help them to write some difficult graph queries. And in the downside of this slide, we can use it's a typical GraphRag workflow. We can use LM to extract the documents, to extract the triplet from documents and construct a graph, and we can use LM to retrieve the necessary information from the graph and generate output for the users. And also, another observation from our practice that the next step is agentic systems. Speaking of the text graph, you may think it just helps the users to write queries, but from the perspective of the agentic system, LM is thinking, they are thinking, and they are generating the text, but the graph, the interface now is a graph query. So if we want to bridge the LM to the graph, we need the text to graph. It's important. It's a key component here. So here comes to our motivation. So the LM makes the industrial grade text to graph query possible, and this text to graph query is key for the future graph interaction with the LM. But the situation is the challenges here is we still lack enough high quality text to graph benchmark and data set. So, and we just approved this text to graph query proposal last day. So maybe you can see a official announcement in short. And here we have multiple members here show their interest and take part in this project. And we have the members using Cypher, ISOGQ, and the CirclePGQ. And when we trying to build this project, build the data set and the benchmark, we may need to define intermediate language for all these graph queries, and this will be expanded later. Yeah. So the objectives and the intended outputs for this text to graph query project is we are going to design a graph intermediate language, and we are going to design the dataset construction framework based on the intermediate language. And with the framework, we can generate high quality dataset for the future training and the evaluation, and we can define the evaluation metrics and design the Intel text to graph query benchmark. So that's our intended outputs. And to do this, we also incorporate existing working groups in LDBC like the LEX, the LDBC extended graph schema, and the G-code implementation working group. And so the interrelationship between these working streams in this project, the next working stream, we are going to define the graph types, the constraints, and it can help to support the graph intermediate language for the graph construction framework, and the G-code implementation working stream, they can help we help the Text2GraphQuery working stream to align to the standard G code. So that's a interrelationship.